Hi folks, today I bring you a panel that uses the PT6312BLQ. As we already have several videos about this driver, as well as the possible methods of providing it with the necessary voltage, we will dedicate ourselves to the details about the VFD control, which has a small complication in the grid number 4 of the VFD. As always, in case you recognize and know the device where the panel belongs, let it on the comments, please. A small code example is created for a clock, and it is about the steps necessary to overcome the difficulty created by the VFD manufacturer in the segments connection of the grid 4. Normal, when the segments follow the same order in the internal connections of the VFD within the various digits, it is easy to control them. When they vary, it becomes a little more complicated. I remind you here that we can always disassemble the original VFD and implement any other, even if the pinout does not physically coincide with the PCB board. We can use external wires for this purpose. Of course, these require new identification of the digit segments and a possible need to adapt the code. Adapting the code will certainly involve a simple modification of the array created for the numbers or alphanumeric chars. This VFD allows a distribution of the digits related to hours, minutes, and seconds in orderly manner with a space between them. It is not mandatory to use the both dots as a separator, but it can be easily activated by forcing the bit number 8 of the grid 2 and 3 to do it. Let us address the difficulties of the VFD control. If we pay attention to the numbering of the segments, that is the 1 that is in the position of the A in the 7 segments digit standard order, we will see that there is a difference in relation to the first digit of the grid number 4 because it is number 2, while in the other digits of the other grids keeps 1. These details represent a difficulty that must be overcome by a second table for the digits used or by applying a shift to all of them when sending to that digit. This is what we use, but it is not as simple as a simple shift since the segments start from 0. So, segment number 8 that belongs to the segment C is already part of the second byte of the digit's memory position, which implies one more operation to make it correct, which is the actual forcing the bit to the second digit, but only in the digits where the C is used, namely digit 0, 2, 3, 5, 6, and 8. Of course, there are many other ways to perform this operation, but I try to leave one that is easy to modify for a general use. Because the panel have 5 keys, I use these keys to adjust the clock, and they have the sequence of byte 0, bit 0, byte 0, bit 4, byte 0, bit 5, byte 1, bit 4, and byte 0, bit 1. This is the sequence of the keys implemented over the PT6312, okay? They depend of the hardware connections to the driver. The actions of each key is increase the hours, decrease the hours, increase the minutes, decrease the minutes, and reset. Okay? As you can see, the clock have the space between each group of the key, the digits, but this is implemented in the VFD. Is possible activate the both dots, both these grids here. As I suggest, I will remove the original VFD of the panel to make the connection of the one external. I check pin by pin and the VFD is ready to remove, okay? It's out. Now we have our PCB ready to connect here the wires to implement one external VFD. As we expected, after implement the external VFD, the result is not so beautiful. The order of the grids start at right, digit 1 go up to 6. Segments start in the left from 1 and go up to 16. I like remember in the original VFD we have 2 digits by grid. Okay? A total of the segments in one grid is 16. We have 7 of the first digit, 7 of the second, and sometimes 2 as a digit predefined. Is a score or semicolons or something. Here we only have 7 segments to digit, and we have also 2 predefined symbols like a dot and a semicolon. This is the result we get after fill the first byte of the table of the numbers, all with digit 1. Our clock is working normal now after implement a new table to the numbers, and you can see the skip of this grid and this grid here. They are done by the connections of the wires here. I skip the position I want and it's done. Of course, you can do tests removing the wires and connecting the other position or change the grids. Okay, now is one lot of options you can use.